Good morning, everybody. So welcome to our newest edition of the Builder Forum series. We have a pretty packed agenda today. So before getting started, I would like to acknowledge that I would like to acknowledge the traditional territories of the Coast Salish people, and in particular, acknowledge our relationship with the Ketsi, Kwantlen, Mitsui, and Semiahmoo First Nations. Now, before getting started, we do have some housekeeping notes. Um, if you are joining from an iPhone, we recommend you to sign into your account and not as a guest. We have been having some technical difficulties with the chat option. So if you do not have a Teams account, I'd recommend you to, okay, you can join in as a guest, but then you would not be able to ask your questions on the chat. If this is the case, so I mean your chat box may be disabled. Now, if this is the case, you may raise your hands. Uh, just yeah, you may raise your hands using this option, and we will unmute you to ask your questions. Now, one more thing, like we do see a lot of people with only their first name or like one name during the registration. Uh, Please make sure you have your first name and last name because this is required for the credits. Now, if you haven't done so, maybe you have to sign out now and like re-log in again so that this will be easy so we don't have to have any problems during your credits. With that, I'm going to hand this over to Kevin, and he will be taking you through the webinar. Thank you.
Hey, morning, folks. Gene, can you just give me a thumbs up if you can see my screen? Is that me?
Yes, I can. I can.
Okay, great. Okay, morning, everybody, and thanks so much, Gene, for getting us started. And yeah, as noted, it's important that if you did log in with one name, that you log out, come back in with both names, because otherwise you won't be able to get your credits if that's what you're looking for. So thanks again for joining us for our summertime Builder Forum series, step 4 in the township. This is presented by us and Pat Cuthbert of AquaCoast. And as noted, it's been a really long time since we've seen you. That means we've been up to a lot, and I'm sure you as well. So let's hit the ground running. Our agenda is packed. So we'll start off with a recap of what we learned last October from Larry Clay and Nicholas Bell on the IDP, or integrated design process. We'll then move on to a very interesting project that we need your help with, and it's on materials or new materials in BCBC compliance. We're then going to talk about a very exciting series of workshops that are offered for you. This is going to be effectively our premiere or launch of the workshops. We're very excited to share that with you. We'll then spend a very short amount of time on some of the updates to the BCBC 2018 and revision 5 of it. Revision 5 took effect in May 1st. We'll also highlight another design resource for all of you folk on how we are seeing buildings change in terms of form. Jean will then take us down the compliance corner and give us some tips and tricks on how to get through BP or on applications smoothly. And then we'll get to our meat of the day, our lecture, which is step 4 in the township, and then we will close. Note, and as Gina had highlighted, if you are on an iPhone and you're having some issues, there are some other ways to communicate with us, but we really encourage that you chat with us. Please ask questions in the chat. Please talk to each other in the chat. And as well, you can even ask your peers and your colleagues in the chat questions or provide comments or answers. Okay, so hitting the ground running, recapping on our last Builder Forum series, which was on the integrated design process and Part 9 buildings. Larry Clay notes that the IDP treats the house as a system, recognizes that each element affects the whole. As part of the integrated design, there are many different players. There's the architectural designer, homeowner, builder, energy advisor. There's a swath of people involved, and it's important that as we enter more and more or different design or high performance design that we communicate with each other, such that later in the process we are not kind of stuck with challenges that are hard to fix. Nicholas Bell of Qualico talked about their net zero home, their fully net zero home here in Langley that's under construction. They were able to achieve, or they're targeting and probably will achieve, net zero status using, as you can see on the left, conventional building techniques or traditional building techniques, and still they're meeting the higher standard that we have here. And he highlighted in the lecture that IDP played an important role in that. And if you weren't there for that lecture or you want to see it again, we do have it all on our website, and including all of our past lectures. Right there at the bottom, it's at tol.ca/gblearn or Green Buildings Learned. We always provide a survey once we follow up from our workshops, and we deeply appreciate your participation in these surveys because it tells us what's going right, where we can improve, and other pieces of very important information. And here's us reporting back on the last survey we had on our last lecture on IDP. We found that 98% of attendees were somewhat or fully satisfied. Some folks noted that they learned, remember to insist on IDP at the start of the project. We're very satisfied with the presentation. Possible improvement might be to add additional links to literature, and thank you for that feedback. And I should note, in our website, GB Learn, we do have the slides for all of our previous lectures, and if you do want to see those links or more links to literature, please open up that that PowerPoint, and you'll find links, a number of links that Larry Clay offered to us. We had 215 attendees. That was a big one. And a metric we like to follow is how many people are learning something. And we saw that 85% of attendees had increased confidence in building to the step code through the lecture. Thank you for continuing to provide information in our surveys. Okay, this is important. We need your help. We have hired a UBC scholar to conduct some very interesting research. And it's roughly titled Products Used in New Construction and BCBC Compliance. The premise for this research is new and high performance design is calling for new or different mechanical systems, likely increased insulation, higher performing windows, for example, potentially changes in building form. And where we're focusing on is new materials. Now, with new materials or any material, the BCBC has section or division B, which tells us what type of materials are acceptable in construction. However, there's a question is arising, and we're seeing this question asked more and more often. What about new materials? Are they acceptable? And if they're not, or it's unclear or uncertain, do you, the applicant, need to spend more time to process them? That's an important question I think that you all would like answers for. So this project that we are taking on right now is to help you understand what your options are. So we need your help, or you need your help, we need your help. Check your inbox. You probably have already received an email from Agene or Green Buildings asking you to participate in this survey. The survey is very short. It's very simple. We're asking you to tell us what new products you are using or considering to use. If it is not you who does the procurement in your company, please share that survey with who does. Our scholar will then select up to 40 different products and process them through the BCBC. Then those products will be labeled straight up acceptable. You're likely fine to use them, or they will probably, or it's in a different bucket, probably needs to be processed through alternative solutions. So depending on what you want to do, if you want to try out new products, and that's great, it may take you a little bit longer to get through the process. If you want to kind of take conventional or traditional building practices and not have to worry about that, you'll probably want to stick to the more acceptable products. The report will be created and then shared with industry widely. This project it does have a deadline. The link is in your website, and maybe Jean, if you could put the link to the survey in the chat as a reminder, that would be helpful. We do need our input as soon as possible so our scholars can get working. So please submit the survey ASAP. If you have questions, go ahead and put them in the chat. Thank you. Oh, let's see, is this going to work? Okay, this is very, very, very exciting. This is big news. By the way, put your volume up on your device. We're going to show you a bit of an ad in a second. This is the world premiere of a very large project we've been working on with a partner developer called Streetside on, otherwise I'd say one of the most innovative and large scale series of workshops that we've probably seen in a long time. So without further ado, here is our ad to our Step 5 on-site workshops. Gene, do you see a video playing?
No.
Of course that has to. Okay, come on. Cannot play media. Okay. Gene,
Right. Yeah.
that's funny. Sorry, gang. We thought we had some of those bugs figured out. Okay, now
yeah.
what?
Yeah, let me try that. Maybe I can share my screen and like show it on YouTube.
Okay. Bear with us, folks. This is our advertisement for our workshop project.
Okay.
Do I need to stop sharing?
No, I got this.
Okay.
So what do you see now?
Sure. Just your videos of you and Kevin.
Oh, okay.
Yeah, I think you're not sharing. I think.
Right. Okay. So now, yeah, do you see this one?
Real quick. Yes. And
Oh, wait a minute. Sorry, I have to also share using the audio. Okay, that's it. Okay. All right. So
we are excited at the Township to have the opportunity to partner with both BCIT and Streetside Developments in offering this workshop. The Township invites members of the construction community to learn of new methods and materials in these educational sessions, and attendees of the workshop will receive value in the opportunity to network with their peers and hear tales of success, as well as potentially demystify any concerns in moving forward in achieving energy-efficient construction.
When the Township of Langley called us and said, would you come on the road and deliver education on site, we thought that's perfectly aligned with what we do. And we're going to be hands-on and practical and have fun at the same time. What I find interesting when we do partnerships like this one is that we also get to learn a lot from those who are actually doing it. So working with the Township of Langley allows us to understand a permitting point of view. Partnering with Streetside allows us to understand elements of real life. So those partnerships are win-win.
The net zero is a significant shift. By 2032, we've all got to get it sorted. It's not that long in the life of buildings and construction. We're only building 4 buildings this way, not the entire project. But to really make this bigger global shift, we've got to share our knowledge. So the next step naturally is to now invite others to come and see what we're doing.
Whether you're interested in design, selling, you're a trade, a contractor, an architect, an engineer, there's going to be something for you. The more people we can educate, the more we will be able to transform the industry and meet our climate change mitigation goals.
all right, Kevin, like I'll stop sharing.
Okay, great, thank you. And by the way, can you see my screen now?
Yes, yes.
Okay, folks, so that's it. That's our launch of our brand new, very exciting project. It's our Step 5 on-site workshops. And I think the commercial did a great job of explaining what it is, and I'll give you the specifics here of the 3 workshops that industry is invited to attend. I do want to highlight before I get into some of the details here that attendance or seating is very, very limited because these workshops are happening live on an active construction site. Space is very limited. It will be first come, first serve. Okay, so one of the workshops that we'll be highlighting is on airtight envelopes. Do you want to learn how to design and construct high-performance envelopes that meet the demanding airtightness requirements of Step 5 of the BC Energy Step Code? Attend this workshop. The workshops are held for this one on August 1st, 5 to 7 p.m. and August 3rd, 1 to 3. All of our workshops, we will have 3, are staggered between 2 different days, one in the afternoon and one in the evening. And this is to allow the maximum amount of people to have ability to come either during the workday or after, depending on your schedule. As well, there will be a tour of the home mid-construction and an airtightness test. I want to also highlight, because seating is very, very limited, that those who register are within the learner audience that we're targeting, and that's on the left of the screen here. There's architects, envelope consultants, builders, contractors, developers, energy advisors, anybody who is specifically involved in the design and construction of airtight envelopes. Another one of our workshops is on high-performance mechanical systems. Learn about high-performance, low-carbon mechanical systems and appliances and considerations for designing for and installing these systems. Plus, again, a tour of the home and an airtightness test. These lectures will be held on August 1st, 1 to 3rd, and August 2nd, 5 to 7. And we will have one more workshop available for this round, and this is for this lecture is primarily very focused on the building officials industry, or for building officials, and this lecture will focus on learn how a developer, municipality, and energy advisor adapted to building, permitting, and designing to the BC Energy Step Code in an engaging and interactive panel discussion, and a tour, and an airtightness test. This workshop is not open to the general building industry. We really want to ensure that building officials have the first go at it. If there's any space left over, we will open it up to everybody else. So as noted, registration is very limited due to space, 50 seats roughly per workshop, first come, first serve. Again, remember, register only if you're one of the recommended audience members. Also, avoid sending your whole team. It would be great to have as many people as possible, but that's impossible. So maybe you can elect one person from your team to attend, and that will leave more space for others from other businesses and companies. And as well, if you are not local or you're not able to attend in person, we have directed a fair amount of resources into ensuring that all of the content will be accessible after the event. So we will have videos, we will have presentations, we will even have separately filmed tours of the buildings itself, so you can watch as a learning tool later after the workshops. Also note, snacks will be provided. We'll present the link. Maybe Jean, you can put the registration link in the chat. Please maybe register after the lecture is done, so you can focus. But I do recommend that registering sooner than later is probably wise. Okay. All right. So May 1st, 2023 came revision 5 of BCBC 2018, which primarily had changes or updates to the energy sections of the code. So I'm not going to go over all of it, just some of the bigger pieces. So some of the revisions included, but not exhaustive. Across the province, for Part 9 buildings, Step 3 is now the minimum base code. Now, you're probably, if you build in Township, and you probably have been, you already recognize that Township has already been at Step 3 for some time, and that Township has already been in step 3 for part 9 buildings for some time, and as well, the township has been at step 3 for part 3 residential buildings as well. So this, if you're building here, this is not new to you, but if you operate in other municipalities, step 3 is now the bare minimum. As well, there happens to be as well an alternative path, a prescriptive path for part 9, which is equivalent to step 3, but also should note that this is only it's only permissible if the municipality had issued a bylaw allowing it. If the municipality had not issued a bylaw permitting the prescriptive path, you cannot apply for a BP with a prescriptive path. Also note that step 2 is now required for applicable part 3 buildings across the board. So talk to your consultants if this is if that's some of the buildings you do, like for example, institutional buildings, that's what you build. Talk to your consultants and see what that means for you. And as well, I'll also note that GHG emissions has been added to the BCBC in terms of providing local governments tools to be able to limit emissions in new construction. And much like how step code started, it is voluntary. It's voluntary for municipalities to adopt. Take a look at 9.37 of the code or 10.3 for more details, and talk to your consultants. Okay, some township code updates. On March 13th of this year at the regular council meeting, mayor and council directed staff to update our part 9 step code requirements from step 3 to step 4, starting 2024. I want to note that staff anticipate a January 1st, 2024 start date. I've pasted the BCBC table here on the right here. So just want to highlight that we are anticipating that we move from step 2 to step 4 come January 1st next year. So that means your requirements are right there in front of you, highlighted. Your air tightness target will have to meet what is now called air leakage tier 3. Your mechanical energy use requirements, or otherwise called MUI, is in the table there, 936.63. And your TEDI, or thermal energy demand targets, must be less than 20 kilowatt hours per meter squared. Okay, so if you have any further questions about that, put them in the chat, and you can email us. Moving on. We have more interesting stuff for you. Our last year's Scholar Project has completed and is a very exciting and interesting project as we and other municipalities are elevating minimums and getting higher in our requirements for high performance design. We ask the question, as we enter this step 3, 4, 5, etc., do you anticipate, or do we anticipate buildings to look different? So for example, step 4, 5, passive house, net zero. And if they do look different, can we see how what those changes are, or what they're going to look like, to help prepare to incorporate those design changes into our own design practice? So we hired a UBC scholar, and this scholar examined 40 high-performance buildings, either across the township or buildings within a similar climate zone as the Township of Langley. And the criteria we were examining were very simple. Window-to-wall ratio, or otherwise how much windows. Articulations, or otherwise how complex is the overall perimeter of the building. Was there exterior shading or not? And even orientation. So the idea is, if these buildings that are meeting these future standards, what do they look like? Do they look like very complex or bizarre looking buildings, or are they relatively simple, or are they something in between? So if you would like to learn more about that, and I suggest you take a look at our page, please visit the High Performance Building Database. We have a report and a website that's meant to make it easy to go through the report. The website is almost like a brochure style page where you can skim through, you can look at pictures, the data is very easily summarized, and from there you'll see what trends are emerging in these ultra high performing homes, and if there are some ideas that you want to start talking about with your design teams. So consider these strategies to exceed current requirements and meet future requirements. So take a look there. It's tl.ca at HP Designs or High Performance Designs. And if you have any questions, go ahead and put those in the chat. That's it for me for now. Thanks. I'll pass it to Ajeen for our compliance quarter.
Thank you, Kevin. I've been pretty busy with the chat. Okay, so the idea here is that in order to because we have a lot of changes coming up and we have a lot of questions that's coming up too. I hope you all hear me well, right? Okay. Yeah, so what we want to do here is that help you guys help you with the submission process and hence reduce your building permit application times, like the processing times. So what we're trying to do here is that to make it clear for you what we are looking for. So submission requirements for Part 9 buildings. What you see here is that, as you know, there are 4 different pathways, and each of these pathways got different documentations required. So if we make it clear for you, and you will also find this similar table on our webpage, it's newly updated, which I'm going to go through as well. So for example, if it's a 936.5 compliance, and what you have supposed to submit is a BC compliance checklist and a HOT 2000 proposed HOT 2000 report. Now, if the project is using HOT 2000 as a modeling software, yes, you'll be submitting HOT 2000 report. But if you're using any other software like IES or Design Builder or anything else, eQuest, you will be submitting a custom energy modeling report that summarizes the input and output summary and output results. For a passive house, if your project is going for passive house and showing compliance with equivalent to step 5, then you are supposed to submit a BC compliance checklist and a passive house report. So the BC compliance report, as of from 1st of May onwards, you will be submitting the newest form and not the previous form. If ERS percentage improvement or ERS heat loss reduction and or ERS heat loss reduction is being used as a pathway, here now, because you are comparing it against a baseline, you are supposed to submit a HOT 2000 reference house report as well. What we're talking about is a full HOT 2000 report. We know that as of today, we do have the new checklist where there's an option to generate a report using the HOT 2000, but it's more like a summary report. We are still contemplating that report. We just want to understand what is in there and what is not in there. So for the time being, we'll be asking for the full report, full HOT 2000 report, and maybe in the future we will decide on what to do with this upcoming report, I mean the auto-generated report. So if it is ERS, how we know it is ERS is through a homeowner information sheet. So if it doesn't have a homeowner information sheet, which means it's not ERS pathway. So make sure you submit a homeowner information sheet as well. Now, if it is ERS step code, so if you're using ERS to meet the MUI and the TEDI targets, so which means you don't have a baseline, and so you don't need to submit a reference house report. So what you need there in that case is a BC compliance checklist, homeowner information sheet, and a proposed HOT 2000 report. Now, if it is an ECB, again, similar to 936.5, I would say typically modelers use any other software other than HOT 2000. So you will be submitting custom energy modeling report and a BC compliance report. So that's what we have for part 9. Moving on, because there are a lot of updates to step code for part 3 as well, and we have a minimum requirement of step 2 for all buildings that comes under this occupancy category. So if it is a step code project, at building permit, what you're supposed to submit is firstly a Township of Langley energy intensity report. So this is a township form. It should be signed and sealed by a registered professional. So make sure it is signed and sealed. We have received a a lot of documents without a signature of a registered professional. Now, part three, energy design checklist. So this is going to be any building permits coming in after the 1st of May should be submitting the latest compliance checklist. It is not the and not the previous one. Energy modeling report, you know that most modelers are familiar with this. Thermal bridging calculations, and you can either use the BC Hydroform or you can use like if you're using a software, you can use that. I mean, submit the report to. Energy statement on drawings. So when I say drawings, it's what I mean is architectural, mechanical, and electrical drawings. This is where we are looking for. The energy statements should be consistent with the energy modeling report and the compliance checklist. Now, at occupancy permit, uh, we are we require you to submit the building energy design checklist with the tested air tightness results. So once you have done the testing, you update the model with that input, and then you submit that report. Plus, we also want to know if the air tightness is done as per the building code requirements. So a test report that's showing the air tightness test is being done as per the building code requirements. Now for part three, any other occupancies, any other occupancy that doesn't require a step code. So this is the traditional methods. You know, there are like the prescriptive pathway, the trade-off pathway, and and the performance pathway. So for any of these pathways, uh, TOL energy design intent letter is a township document. It should be signed by a registered professional or an architect or a CRP. For any of these pathways, this is a requirement. Similarly, energy statement on drawings is also like a requirement for all the different pathways. Now, if it is a prescriptive pathway, depending on if you're using ASHRAE or NECB, you will be submitting the NECB and ASHRAE forms. So good news, we do have the link to these ASHRAE forms and NECB forms on our webpage. So you should be able to find it quite easily. Trade-off reports, what we're typically seeing is the comp check report that shows how better the building envelope is compared to the baseline. And for performance pathway, you will be submitting the energy modeling report. So that's it for the submission requirements. So why we are doing this is like, we want to make sure like the package, the submission package is complete, so that we don't want to reduce. I mean, we want to reduce the building permit processing times. Now, this is another tip for you to reduce your building permit processing times. Uh, I know most modelers, most energy advisors and modelers in this call will be having a quality assurance protocol within your organization, but this is something that we do internally. So if there is something that's missing, or maybe if you're doing better than this, it's okay, but if you're missing something, just keep these things in mind. So what do we verify on this for these reports? First thing, we compare the BC compliance checklist with the drawings. Now, what do we check there? We check for the envelope R values. Are they consistent between these documents? Now, the window U value and solar heating coefficients, if the area is within reasonable range. So now it's a tricky one for part 9 because they don't have any particular requirement, and also like because of the density, uh, the architects might be taking the measurement from exterior of the wall or maybe middle of the wall, but the model floor area is calculated from interior of the wall. So there will be differences, and it's more like we try to make sure it's like within reasonable range. If you see a 30% difference, we might ask you questions. It's not that you're wrong, but like it might be right. So we just want a clarification. Why is the area 30% more or less than the architectural drawings? For part 3, it's pretty clear. It's 5% because it's mentioned in City of Vancouver modeling guidelines. This is something that we use for our TEDI calculations. So as per BC Building Code, Appendix C, 2700 is the heating degree days that you should be using for Langley. And this is what we want you to include in your calculations as well. So we verify that. And then mechanical systems, are they consistent? Mechanical system efficiencies, are they consistent? So, and a very high level analysis of the results, like just looking at those numbers, does this result make sense? It might be right, depending on the layout, the geometry, or like the orientation of the building. But we might ask questions, because if we see, okay, this is like a very high performance building, but you didn't do anything specific. So we just want to maybe clarify that. So this is something we verify, BC step code compliance checklist versus the drawings. What we also do is we compare the compliance checklist with the energy modeling report, so which is the HOT 2000 report. The same things we do there: wall, window, mechanical systems. Are the results calculated accurately? Because the TEDI and the MUI calculations, are they done accurately? We have a small Excel spreadsheet. Is the ventilation accurately modeled? I think you might be aware of a bulletin that we put forward on how to model the ventilation in HOT 2000 specifically. So we verify that, and is the right weather file used? So Abbotsford weather file should be used for any energy modeling, whether it is part 3 or part 9 projects. Abbotsford Airport CVEC weather file should be used for your analysis for energy modeling. Now, the last one is we compare the drawings versus the energy modeling report. Again, consistency. Uh, and then these are all like mechanical system consistency, building envelope consistency, and we also make sure if the air barrier are marked on the drawings. So we require that, and energy statement on drawings are consistent with the energy results. So this is, in a nutshell, this is what we verify for. So if there is something that you're missing, maybe to help you improve your energy, like the building permit processing times, this is what we verify. So this is out there. If you have any questions, you can put them in the chat. I can answer that. Now, one last thing from me is we do have an update to our green buildings webpage. I'm going to let me just see. Okay, I just need to put this up here. Do you see the webpage? Okay. All right. So if you type in www.tol.ca/buildgreen, you would reach this page, the green buildings builders page. So we have trimmed down a lot of information because we thought, like, we wanted to keep most relevant information, and we have trimmed this down quite a bit. And because there are a lot of updates to the requirements, the step code requirements in the township and in the province, we wanted to include them all. So we do have some introduction, and then, like, a proposed bylaw changes that Kevin already mentioned. We'll be having step 4 for part 9, these occupancy types. Current requirements. So these are the current requirements for all step code projects. As you can see, because provincially it's at step 2 right now for part 3 buildings, we have them noted down here. Now, for energy compliance, I did mention in my slides, like, you have to be using 2700 for Langley, and Abbotsford weather file should be used. We have specified that in over here. And if you have any questions, you can reach out to greenbuildings@tol.ca. Now, in my initial slides, I had a bunch of like tables. We have the same tables here. So if you are missing something, you can look it up here too. And we do have, so for example, like these links take you to the step code page, and you can download the most recent forms here. And similarly, when you go down, this is for as built. And for part 3 buildings, so this is where you can get the energy intensity report. You click on it, you can download the form. This is the form where you sign it up. And we also have, okay, so this is for part 3 design checklist, takes you to a step code page. We do have some energy statement samples. It's more like a yeah, this is a sample drawing. Okay, I think there's something, I think the link is not working. I need to fix that. Okay. And this is the energy design intent letter for all other part 3 buildings, the energy design letter, and we have a sample energy statements. Okay, so this is the sample energy statement. It's a spreadsheet. You can check it up and you can explore it to yourself. If you have any questions, you can reach out to us. These are like sample energy statements. Now, we also have our GHGDP, the information on GHGDP, the rebates and incentives that we have, and also grants like other external rebates and incentives. Now, if you scroll up, you also have a Green Buildings Resources and Education page, which is where we have all the upcoming educational events, including our Net Zero workshop that's coming in next month. And all the Builder Forum series that was done previously, we'll have those videos, presentations, and the Q&A will all be here. You can find it there. And the UBC Scholar Project. So Kevin was talking about the high performance buildings database. So UBC Scholar Projects, you can check out. You have all the photos, the pictures there. Okay, so this is the database. You can explore it. And that's it. And every educational events and all the resources, you can find it here. Yeah. Okay, I think that's it from me. Kevin, if anybody have any questions, just put them in the chat. I can answer them. Thank you.
Thanks, Eugene. Hey, Eugene, are we on time for one of the first times ever?
Yeah, so I mean, I think by now we should be moving on to Pat.
Okay.
Yeah.
Great. Okay. And thanks, Eugene, for that. Yeah, you can see Gene's been very, very busy updating the website, making it easier for everybody to go through and find what they need. There are a ton of resources there, as Gene has highlighted, so take a look at the site. The intention is to make it as easy as possible to know what to give us and when. So please take a look, and with that, I'm going to introduce our speaker. So if you can see me, Gene, can you give me a thumbs up if you see my screen? Yeah, okay. So I'd like you to meet our speaker of the day. Please meet Pat. Pat Cuthbert. He's a professional engineer and has been with AquaCoast since 2011. Pat's the manager of energy modeling and airtightness testing groups. With meticulous analysis and innovative solution, Pat and their teams contribute significantly to the energy efficiency and sustainability of the construction industry. And Pat's going to tell us about step 4 in the township and some tips and tricks on how to get there and all the other interesting, relevant details for you. So with that, I'll pass it off to you, Pat.
Okay, thanks, Kevin. Thanks, Eugene. Are you able to stop sharing so I can share my screen now? Okay. Okay, let me just get rid of this. Okay, that should be good. The city of Delta has just decided to start cutting open the street right outside my office. So hopefully they are on a coffee break, and hopefully they don't resume anytime soon. But if they do, I might switch to my headphones, and that might make the sound better. But if the sound gets really bad, someone let me know, and I can try to switch. So thanks very much. A lot of good information there, and lots to digest. And the purpose of my presentation hopefully will give everybody a snapshot of what we've been working through over the last couple of years with the step code, and now specifically, obviously, focusing on part 9 and what it's going to take to meet steps 4 and step 5 of part 9. So thanks very much, and hopefully this presentation is beneficial to everyone. And land acknowledgement. So yeah, AquaCoast Engineering acknowledges that we are located on the traditional territory of the Tsawwassen and Musqueam First Nations and all of the Holcominium speaking people who have been stewards of this land since time immemorial. Okay, just a quick overview of my presentation. I will try to keep it under an hour, and as we budgeted time-wise here. So I'll start with just an overview of the step code. I'm going to assume everybody here is somewhat familiar with the step code, so I won't get into too much of that. And then I'm going to break it up into sort of two separate sections. One will be focusing on the building enclosure and architectural design. The second one will be more of HVAC and domestic hot water design and best practices. Then I'll move on to sort of 4 examples of Part 9 construction, 2 single families and 2 townhomes, and what it's taken to sort of meet step 2 and step 3, everyone's used to, and then what it takes to sort of push those existing projects up into step 4 and step 5. And then a few other slides at the end just on overheating or thermal comfort, because this is a very hot topic, pun intended, in the industry, and it's getting a lot of attention from government and officials, because I think it's a very important thing to sort of bring up and discuss as we move into more high performance buildings, something that shouldn't be forgotten. And then just a slide on some rebates and a discussion on that. But I think Kevin and Jean have really good points in their presentation on all the resources available to that, and I'll highlight the integrated design process again at the end. So moving on here. Yeah, so AquaCoast Engineering. I want to thank Township for this opportunity. Again, my name is Pat. I'm a principal at AquaCoast. I've got one of our energy modelers and energy advisors online here as well, Jessica Allen. She will hopefully be able to answer some questions you may have in the chat. Hey, Jess. And maybe in the Q&A section. She's a tremendous resource when it comes to step code, both Part 3 and Part 9. But specifically Part 9, an incredible resource. And so hopefully we can answer some of your guys' questions today. Yeah, AquaCoast, we've been in the business for over 18 years. We offer services in building enclosure consulting, energy modeling and sustainability consulting, roofing and re-roofing consulting, and of course, airtightness testing, window testing. Any other questions you've got, maybe you can check out our website and see the different services we provide and industries that we work in. Okay, so step code, like I said, not going to get into too much detail because I assume everyone here is somewhat familiar. But of course, it is a non-prescriptive approach to building homes and the energy code or requirements for building homes. It focuses on 3 metrics. And again, I'm going to be focusing on Part 9 here, not Part 3. There's a bit of a difference, so we'll just stick to Part 9. TEDI, or thermal energy demand intensity, measured in kilowatt hours per meter square per year floor area. You can think of this as the building enclosure heat loss, or the energy that you lose through your building enclosure. The MUI, which is the mechanical energy use intensity, again, measured in kilowatt hours per square meter per year. This is the mechanical energy consumption, and in Part 9, this is restricted to the energy used for domestic hot water, heating and cooling. And then the third one is the airtightness, measured in ACH 50. Again, I won't go in too much detail into how the test is performed, but we'll talk a little bit about the sort of best practices and designs for airtightness. And again, every one of these slides could be a presentation in its own. So just bear with me. There's going to be a lot of data and a lot of information presented here. I'll do my best to get through it, but just keep in mind, like, there's a lot of info here, and you could dive deep into any one of these topics. So this is a pretty high level overview of all of them. So the step code. This is the table, steps 1 through 5. As Kevin and Jean mentioned, steps 1 and 2 are no longer available as of May 1st, 2023. But this, the targets here on the screen, you can see you've got your mechanical energy use intensity. I've included the percent improvement columns. This is a alternate path to your TEDI and MUI, modeling the building and comparing it to a reference house. I won't get into too much of that today, but just wanted to put it there on the table because that is, there's alternate paths to compliance through the step code and through the modeling process. So under MUI, you can see that the numbers in red represent the targets for heating only, and the numbers in blue represent the targets for cooling. You've got your percent improvements, your TEDI, your percent heat loss, and your ACH. targets, and obviously as you go higher in the step code, these targets come down and or up for percent improvement to build more energy efficient homes. So this is the proposed table. Kevin and Jean mentioned this for Township, whereby we'll start at a step 4. And I just included a line on the bottom there to just show passive house. I think a lot of people are familiar with passive house and net zero. I didn't put net zero in here, but passive house, a lot of people in the industry, because passive house has been around for some time now, think of that as the benchmark or the high water mark for energy efficient design. And so you can see how Teddy compares to passive house. The MUI is a little different. Like I said, MUI in Part 9 is different from Part 3 MUI. So you can't compare directly with the Part 9 MUI to passive house, but Teddy is relatively similar. And then you can see the ACH. So we're approaching passive house levels of design when you get into the higher steps of the step code. And then also alluded to is the fact that in the future, we will have to pay attention to our greenhouse gas targets. There's municipalities, Vancouver and others, that have already implemented this, whereby you need to hit greenhouse gas emission targets with your designs. So I didn't put any targets in there, just wanted to put this slide up to show, thinking, developers, builders, designers, everyone should start thinking about greenhouse gas emissions and understanding that in the future, we're going to have to be hitting those targets and designing our buildings and choosing our equipment so that we can hit greenhouse gas emissions targets. Now, okay, moving on to the sort of 2 main sections of the presentation. This first section, I'm going to focus on the building enclosure and the architectural design. And that will pertain to the TEDI, or percent heat loss, and the airtightness sections of, or targets of the step code. So I'm going to talk briefly about VFAR, or vertical floor area ratio. This is the ratio of your vertical envelope components, i.e. walls, compared to your floor area. That's a VFAR. That's what that metric is. I'll talk a bit about structural impacts. What are a couple key structural design changes or items that you could maybe just highlight and pay attention to. Briefly touch on the mechanical room, or where you locate equipment has an impact on airtightness and performance. Talk about the windows and door selections you're going to be facing with the higher steps of the step code, and airtightness. So just talking about designing, budgeting as well, with airtightness in mind, because obviously that is a key part of the step code. And the higher you go in the step code, the harder it is to hit targets. So first off, VFAR, or ratio of wall to floor areas, is a measure of how efficient your building envelope is, i.e. the greater the volume of your building to the lower wall area, the easier it is to hit these targets. So this is just a graphic on the left here. I think my laser pointer might be working. Yeah, this graphic here is in a BC housing document where they took a building, modeled it, hit a target, hit a TEDI of 15.1, and then they changed the geometry of the building and saw how that impacted just without changing anything else. And you can see how these are plan images of a building. You can see how as you create more wall area, it's harder, your TEDI essentially goes up, or it's harder to hit that TEDI target. So it's important to keep that in mind. But I also want to highlight that, as Kevin mentioned, we can still design and build beautiful buildings and buildings that people want to buy and live in while meeting high performance targets. The images on the right are of a passive house townhome complex. As you can see, great, beautiful looking buildings, have rooftop patios, excellent development, and passive house level of design. So it's not like we have to abandon beautiful buildings here when we're building high performance projects. So you'll see these 4 images later in the presentation, but this just sort of quickly shows you on the left-hand side, you've got on the top left corner what I would say a conventional or typical townhome development, a sort of simple, conventional single family. And then on the right, you've got more of a contemporary style townhome with rooftop patios and a bit of an articulated facade. And then the image here is obviously of a custom single family home. And later in the presentation, show how the designs, what factors need to go into designs to sort of make these projects hit the higher steps of the step code. Structural. Okay, starting off on structural components. I'm just gonna a couple slides here to show you some considerations. These are nothing here is mandatory. Like I said, this is a non-prescriptive compliance path, this step code. So I'm just highlighting some of the main items we've come across in the last few years of designing and modeling and field reviewing, testing these projects, and just highlight a few things here. So first on the left-hand side is the truss heels. So obviously, more high-performance buildings, we're going to be putting more insulation in our attics, and you may need to consider the heel height of your trusses when you're building higher levels of insulation, i.e. R60 is common for steps 4 and step 5. So keep that in mind. There is a provision in Part 9 to reduce some insulation for a certain depth. So just consider that. The walls, this is a big discussion. Eventually, when you build the higher steps of the step code, you're going to be faced with the decision of, do I build a 2x6 wall with R24 bat with 2 inches of exterior insulation, or do I increase to 2x8 construction? A lot of these higher step projects cannot meet the TEDI target without some improvement to the walls. And so you're going to be faced with this question, whether you put the insulation outboard or you make your walls thicker. This could be 2x8, it could be service walls. There's many different ways to achieve this. This is probably the most common. And so I just wanted to highlight there that that's a question you're going to be deciding on when you move to the higher steps. Pros and cons for both. The next one will be cantilevered balconies. Structurally, you got to think about this. The photo on the left is of projecting TJIs, so just cantilevering your floor system out, whether it's TJIs or dimensional lumber. And the image on the right is cantilevering out beams. What's not shown are the joists spanning between those beams. So the photo on the left shows TJIs cantilevering out through your envelope. Every single one of those TJIs is a hole in your envelope that needs to be sealed. So you got to pay a lot of attention, details, sealing every single one of those holes in your envelope. Photo on the right is simply projecting 2 beams out. You seal the beams, and then no other penetrations for your balcony framing. Of course, the photo on the right likely achieves a higher level of airtightness because it has less penetrations and easier to detail penetrations, i.e. rectangular shapes beams are a lot easier to seal than the I shape of a TJI projecting through your envelope. Fortunately, I don't have any Part 9 photos of this. These are just obviously from some Part 3 projects. And moving on to the sort of slab on grade or thermal break detail. Been around for quite a while now, even before the step code, when we introduced, or the code introduced, thermal breaks. And this just shows there's kind of 2 different ways to achieve this. You will have to include this if you're not including this already in your Part 9 designs. You will have to include a thermal break at your slab edge. You can achieve this either breaking your slab where it meets the footing, or putting insulation on the outside or skirt insulation on your footings. 2 different ways to achieve it, kind of up to designers, up to developers, builders, how you want to achieve that. And then on the right-hand side, there's just some consideration about how you're framing and the corners. So like Jean said, Jean said, you do have to perform these thermal bridging calculations, and the modeling and the softwares take into account thermal bridging. And so how you frame your corners makes a bit of an impact. There's a modified 3-stud corner producing some framing, or there's even a 2-stud corner using drywall clips. Not saying you have to do either of these, but these are just a couple things that make a difference when you're getting into the higher steps and really fine-tuning your performance. And the next one, like I said, was just a quick discussion about the mechanical room and where you locate it. Of course, common sense would say you want to locate this equipment and everything inside the barrier or the air barrier location of your plane of air tightness. So that's the red dashed line here. You can see you want to put this in. The photo on the right is of just highlighting how much equipment goes in and out of this room, and this is under the stairs in a townhouse development. So just be mindful when you're locating this and installing this equipment and everything that connects to it, water lines, gas lines, ducting, all of this stuff, that every penetration through your air barrier needs to be sealed and is potentially a source of air leakage that may impact your target, your test, and your compliance. You'll see lots of more photos in the next few slides of air tightness and the penetrations. And windows. So big decision everyone's gonna be faced with as you build the higher steps is what type of windows to choose and what performance to choose. So as a rule of thumb, you want to start, I would say, a minimum U value. Well, I guess you think of it as maximum U value of 1.4, lower U value, better performance. The U value of 1.4 is the Vancouver window. That 1.4 number has been built into the VBBL for some time now. So a lot of window suppliers have that product readily available because that has to be used in Vancouver. And so that's the number that we sort of use as a baseline for all of our step 3, 4, 5 up models. And it's available casements, awnings, sliders. I mean, that's a decision you got to make early. Starting sliders to casements and awnings. Sliders probably have a slightly less performance, both in U value or thermal and air tightness. So keep that in mind when you're choosing what windows you want on your buildings. Double versus triple, as you move into the higher steps, you're going to have to make that decision as well, whether you want or need double versus triple glazed windows. There's a lot of pros to moving up to a triple glazed window and beyond thermal, acoustics mainly the one. So there's other benefits. There's multi-point locking. In order to meet the higher air tightness targets, you may need to consider multi-point locking doors and energy efficient and airtight doors as well, not just windows. The doors play a big factor in the performance of the building, especially in the air tightness testing. So the image on the right actually is just something that Centra Windows put out. It's a sort of a quick guide to help people design and budget for higher performance buildings. And if you can't read that slide or the data there, I'm sure Centra would be happy to send this to you. But it just shows a base dollar per square foot of a pretty standard U value of 1.6 sliding window. And as you go down on this chart, the price goes up, but the U value goes down. So it gives estimators a tool to help budget for these improved window performance. And the air barrier, a very important part of the step code and high performance buildings. So what I want to highlight here is you need to design and budget with air tightness in mind, not just something that happens at the end of the project and you check a box. It really should go into the design very early and the budget very early and be at the forefront of your thought process when you're designing these buildings. And so what I'll list here in the photos I'll show you are sort of the 4 main strategies we have seen over the last few years in air barrier. So the first would be your conventional or 6 mil poly approach. This is where the 6 mil poly you install on the inside of your wall assembly acts both as the air and vapor barrier. That's taped and sealed with conventional means and methods. I'm sure everyone here is very familiar with that approach. That's what's been utilized in the industry for many years now. See my pointer there. Yeah, that's this one. And then the exterior taped weather barrier or taped Tyvek approach would be this photo here. This is the approach where you use a synthetic sheathing membrane for both your weather barrier and your air barrier. This membrane is applied, typically stapled to the wall, but all the seams are taped airtight and sealed to the windows and any other openings. And this functions as both weather and air barrier. So this is another common approach. It does have its challenges with articulated design, with projecting balconies or features to maintain that air barrier as you go around your building. The third one would be a self-adhered vapor permeable air and weather barrier. So that's a photo top right corner here, using a vapor permeable peel and stick to wrap your building that functions both as the air and weather barrier. Very good approach, very high quality, or can achieve very high levels of air tightness. Yeah, it's a good approach. Last one I will mention is the taped sheathing approach. Unfortunately, I don't have a Part 9 photo. This is a photo of a Part 3 building, passive house building we did in Fort St. John a few years ago. And this is an excellent approach. I put a star beside it because I personally really like this approach. It can achieve very high levels of air tightness. This is a practice that comes out of passive house construction. And I like this approach because it's easy to do. The builder developer can take this on themselves. You don't necessarily need a subcontractor to do this. You can have the quality control all in-house, basically just taping the sheathing. And then the sheathing in combination with the plywood acts as your air barrier. You can achieve very, very high levels of air tightness with that approach. That's to say there's many other ways that you can achieve air tightness. Throughout the years, we've seen lots of different strategies, including spray foam and SIPs, or structurally insulated panels. There's taped insulation on the inside. There's tape sheathing on the inside. There's lots of different ways to do it. I think what you need to do is just talk with your professionals early in the design and choose something that makes the most sense for your team and your development. Lots of different ways. And then this will just segue quickly into air tightness testing. Another thing that you need to keep in mind in both design and construction is the actual test. The photo on the far left here shows in a townhome development, when you go to test the buildings, I'll just preface non-EnerGuide. I won't get into EnerGuide into too much detail here. There's alternate sort of design and testing considerations with EnerGuide. But let's assume Part 9 construction for now, or just straight 936. So when you test these townhomes, we have found the biggest success and easiest method for testing a townhome block is to test the whole block at once instead of testing each individual unit separately. So what that needs, unfortunately, is a knockout in the party walls. We have seen this done typically in a closet or somewhere behind cabinets or something, where some drywall is left out, insulation is removed, so that all units, the building, one blower door can pressurize the building all at once, and you can achieve better results and easier testing, quicker testing, all over. It's basically the standard when in a non-EnerGuide project. Obviously, for a single family, that doesn't matter. You don't need these knockouts. This photo is just of the blower door equipment just hooked up to the front door. You just got to consider that this test will occur at some point. You need power, and you need to have the building prepped and ready and sort of evacuated for the day or for a few hours to conduct the test. You got to prep your building for the tests. When you engage an air tightness tester, they will hopefully give you a quick report or document that tells you how to prep your building. Non-EnerGuide, again, you can tape your mechanical penetrations on the exterior. You'll see in the next few slides why we do that. You need to prep your plumbing. If you have stub outs, they need to be sealed. If you have any plumbing fixtures installed, plumbing traps need to be filled with water. You need to have all the doors installed. If there's any hardware missing, would have to be taped, but make sure your weather seals are installed and engaged. Hardwares can be locked and engaged, and your doors are sealed or in operation, so that your weather seals are engaged. And then just further on the air tightness testing, a few pictures here just to show some of the key things to pay attention to. There's, like I said, you could do a whole presentation on air tightness testing, but just this slide will just show a few critical ones. One of the biggest ones we see is this in townhome designs, the stair over garage on a party wall is always one of the biggest sources of air leakage. This red sort of outline shows from one of our tests, we just saw a large amount of air just coming through the stairs at this penetration. So I won't go into too much detail. It's a very difficult detail to achieve air tightness at. Few different strategies you can employ, but just paying attention to that is one of the most important things. This detail in particular, with a few others you'll see. Spray foam that becomes necessary in a lot of locations with an interior air barrier approach. Just want to highlight here that spray foam can work well, but it can also work not so well when you have ganged framing. As you can see, very difficult to get spray foam into a lot of small gaps between framing, and the results in air leakage through your envelope, especially, and then highlighted during your air tightness test. So just pay attention to that. Another comment here, I don't have a photo, but ganged framing needs to be caulked. So in this case, if this was 2 beams, you would have to caulk this in order to maintain continuity of air barrier at spray foam. These 2 photos here, just want to highlight in townhome construction and even single family home construction, when you have a garage, an attached garage, quite often the floor sheathing over top of your garage is your air barrier, is used as your air barrier, tongue and groove, glued and screwed sheathing. And if it's not taped, or there's holes drilled in it for various penetrations or electrical lines, plumbing lines, whatever, those are holes in your air barrier. So those need to be sealed. Quite often, it's not really known to a lot of people on site that floor sheathing is your air barrier. And so good quality control, good site supervision needs to be there in place so that everybody knows that that's the air barrier and it needs to be taped or sealed, especially for the air tightness test, but for air barrier continuity. And when you prep your building, it's important to prep properly and well. Any penetrations, I think this one was a sprinkler stub out, just not caulked or sealed, so there was air leakage there. Just the tape around the prep for this HVAC grill wasn't done very well, and significant air leakage. And another one we see quite often with forced air buildings is just this floor sheathing again at any furnace register here, taping that to seal the holes around the ducting is important. And we see significant air leakage through that in a lot of our tests. So prepping your building is equally as important as doing a good job at the air barrier. Okay, this slide is a bit of a work in progress. We're starting to track all of our projects, all of our step code projects throughout the last couple of years, and we're starting to get some sort of metrics there. And this graph shows on the y-axis on the left, this is the air tightness test. The blue, or the ACH 50, the blue columns are the target and the gray columns are achieved. And then along the bottom, if you can't read it, these are the different types of air barriers that were used in these projects. And so we've got the mechanically fastened or taped Tyvek approach here on the left, the self-adherent or peel and stick, vapor permeable peel and stick method. We then have the 6 mil interior poly, the taped plywood, and then taped rigid insulation. The numbers on top of the columns just represent how many data points we have for each of these. So you can see with this 6 mil poly approach, we have the most data points. And so a lot of these are very few data points. We're working on this slide. We'll keep updating it as we get more projects. And just want to sort of show here that you can achieve the step 4, step 5 targets with any one of these approaches. But I will say with this interior 6 mil poly approach, it is showing to be one of the most difficult ones to achieve step 4 and step 5 ACH targets. Not impossible. And even with an asterisk here, that out of these 25 tests we've got on this chart, about half of them have employed the aero barrier in order to achieve the 2.5, because I believe 2.5 is the target for step 3, I believe. So won't go into detail about air barrier. If you want to learn more about air barrier, you can Google them or speak to a local rep. So yeah, and then another thing to highlight would be that the self-adhered or peel and stick air barrier on the outside of the building can achieve very high results, and so can the taped plywood. Okay, so I will move on to HVAC and domestic hot water. A brief discussion here on those two topics. These focus on the MUI, or mechanical energy use intensity metric. I will talk a bit about heating only versus heating and cooling. Won't talk too much about gas and electric or electric only. That's a decision you got to make early in the design, whether you want gas and electric on your site, or do you want electric only? There's lots of factors there. I'll talk a bit about HRV versus ERVs and the percent heat recovery you need for those. Quick slide on domestic hot water waste heat recovery. This is something that maybe could become necessary depending on your UE results, and heat pumps and heat pump preheat for domestic hot water, another decision that you'll eventually have to make for your projects. So a quick slide here on quickly as it pertains to HVAC and domestic hot water. High level overview. This is, again, not prescriptive, but step 4 most likely can be achieved with a quote conventional system, a gas furnace, HRV, ERV, 75%, and electric hot water tank, or cooling, of course, with a heat pump and an HRV, ERV, and electric hot water tank. Step 5, however, I have ... here. Very difficult to achieve step 5 with a sort of quote conventional system. Most likely heat pump is going to be your best option when you get into step 5, part 9 construction. Not necessary, not required. Again, there's lots of different options, but probably your least, or your path of least resistance, will be using a heat pump for step 5. Okay, HRV, ERV, quick discussion on this. Won't go into too much detail. I assume everyone here knows basic principles of heat recovery. HRV versus ERV, everybody always asks this question. Simple way to think about it is an HRV is a simple heat transfer of cold air, hot air streams through a heat exchanger. An ERV, using an enthalpy exchanger or enthalpy wheel, captures and transfers latent heat energy. Think of it as moisture, so the energy in the moisture of your air as well. Rule of thumb, it's kind of HRVs are best in cold climates, and ERVs are best in climates with long, dry winters or very hot and humid climates. But Vancouver, we're special, and we're kind of in this place where both HRVs and ERVs can work. You don't have to use one or the other, but I just want to highlight it's important to consider your design parameters with respect to humidity when you're choosing an HRV versus an ERV. If you're expecting a very humid environment that you need to reduce the relative humidity, maybe an HRV makes the most sense. If you're not expecting a very humid indoor environment, an ERV may make the most sense. The main difference for a lot of people is just an HRV requires a condensate drain, ERV does not. So keep that in mind. They both offer a range of percent heat recoveries, ERVs and HRVs. They are both relatively similar size, and they both, important thing to note here is they both have a bypass, or should have a summer bypass or boost mode. This is whereby when you don't want or need that heat exchange, you can bypass and just run it in a circulation mode. A lot of people do this in the summer to help cool your home down. And both require filters to be changed. So you got to consider that in your design, located somewhere where it can be accessed and filters changed. Domestic hot water heat recovery. This is a very relatively simple design consideration that higher steps of the step code, higher performance buildings should consider. It's essentially just capturing the hot water off of your waste stream. These are simple products. You can buy them at Home Depot. This website here, Natural Resources Canada, great website. Lots of information, lots of different products there. excellent resource if you want to look more into this. It's essentially you install this copper coil on your main stack or your main waste line, and it just captures the heat coming off of that line, transfers that heat to the water that's going to your boiler. So obviously less energy used to heat the water at your boiler. And so important to just, if you're going to go with this, talk with your plumbing contractor about location and what this means as far as cost and location for plumbing. And just the photo there, interestingly, is these types of systems have been used on large projects, Part 3, residential, commercial, institutional projects. This is just a photo of what that looks like in a large scale application. Very interesting and really interesting technology for reducing overall energy consumption. And heat pumps as they pertain to domestic hot water, call this hot water preheat or heat pump preheat for domestic hot water. I won't go into too much detail here. This is something that may or may not come into play in Part 9 construction. Often comes into play with Part 3 construction. This is just using a heat pump to preheat the water before it goes into your boiler to use less, so you can use less energy or less gas to heat your hot water. And this is available in different configurations. You can use a standalone heat pump integrated into the hot water intake system, or there are combo heat pump hot water tanks. I don't think these are very common in our climate because obviously with the combo, and this is the sort of diagram here, the combo unit, you obviously have a heat pump sitting on top of your hot water tank, and this takes a warm air stream and exhausts a cold air stream and runs a compressor. So as you can imagine, if you have that inside your house, considerations for that cold air exhaust stream need to be taken into consideration, plus noise. So I think this photo is from Australia, where this may be more common to have your hot water tank outside, where it's a climate where it's okay to have your hot water tank outside and have that that heat pump hot water tank run outside, and it works well. You may see this in townhomes with small units because each unit has a full domestic hot water load, and then therefore, if you have a bunch of small units with these full domestic hot water loads, the building as an aggregate may be harder to meet the MUI target. Sorry, the construction's really ramping up here, a bit distracting. But yeah, obviously consider this early in design and consider that there may be some local bylaws applying to location of heat pumps and hot water tanks. And just a quick mention that this pertains to the airtightness as well. When you're choosing and installing your HVAC equipment, you need to understand that the furnaces and equipment themselves, HVAC equipment themselves, and the ducting are not airtight. These equipments are not airtight. So when you design and prep or install your equipment and prep for airtightness testing, keep that in mind. The ducting in the equipment is not airtight. So if it's fully inside your air barrier, it doesn't matter. But if it penetrates your air barrier, you need to keep that in mind. And this is the main reason why when you're prepping for airtightness testing on a non-EnerGuide building, we tape the grills on the outside of the building. And as promised, moving on to some photos and examples of the ducting. And so what I want to highlight here is that traditional ducting works well when all the seams are sealed. This does not happen very often when the seams are sealed very well, and so we see a lot of air leakage through the ducts themselves. Just a note here from our testers that vertical seams are often missed when in the ducting, and that foil tape is probably the most effective method for sealing them. The sealant is an acceptable method when it's applied well. Foil tape is probably preferred. And just to comment that, you know, the better, not only is better ducting going to help your tightness testing, but it's going to improve the overall performance of your HVAC systems, leading to better performance of the equipment and happier customers, better, more satisfied occupants and customers. panned joist. This is using a joist as an air plenum to distribute air. We would recommend this is avoided if you can. And just some photos here showing why we would not recommend it. It can be done, can be installed well, but we quite often, whenever we do see pan joists or air plenums, we see them not installed too well, or there's large or significant gaps in these pans, and leads to significant leakage through air tightness testing and through operation. So just keep that in mind. Again, duct penetrations, where the ducts penetrate your building envelope, it's important to pay a lot of attention to that. Spray foam, it doesn't stick well to metal, to sheet metal, doesn't stick well to poly either. So not always the best solution to just spray foam around the ducts when they penetrate your air barrier. Tape is definitely the preferred method. And again, like I mentioned earlier, sealing these registers in your floors is very important. We see a lot of air leakage around that. And kind of I've said this again, just don't assume any duct is airtight when you're planning and for your air tightness test. Okay, we'll move on. Sort of that kind of concludes this high level discussion on building enclosure, architectural design, and sort of the basic HVAC and domestic hot water principles. What I'm going to move to here is just 4 examples of Part 9 projects that we have modeled that meet step 2 or step 3, and then what it took to get up to step 4 and 5. There is a lot of info here. You probably can't read all of this, and I won't go through all of this in detail, but I just will try to highlight the sort of results here. So starting, this is as you remember in the earlier slide, this is a sort of custom single family home, or a typical single family home with a lot of articulation. And so just starting with steps 2 and step 3, 2x6 walls, no exterior insulation, R50 roof. You see that that U value 1.4. This had a combo boiler and an HRV of 70%. Step 2, step 3. So to get up to step 4, obviously all paths needed to achieve the step 4 ATT. We upgraded all of these scenarios. So there's 5 paths here for step 4 that were compliant. All of them had the basement insulation upgraded and some floor insulation upgraded. First path to make it achieve, we had add exterior insulation and triple glazed windows. Another one was add exterior insulation and increase performance of your mechanical system. Another path was add 2 inches of exterior insulation and use a heat pump. Another one was upgrade the windows to triple glazed without exterior insulation and upgrade your mechanical system. And then another one was upgrade your windows, no exterior insulation, and use a heat pump. So lots of different paths. Step 4, all required some upgrade, necessary either combination of envelope and mechanical. Then moving on to step 5 for this one, we're starting with the hardest example. It was all paths was upgrade the HRV % recovery, add exterior insulation on the walls above grade in the basement. And we ran a bunch of different scenarios and found that the only one that we could meet this was with a heat pump. So I just put this here to show that lots of different scenarios were run, couldn't get any of them to pass with these upgrades, and we moved on to a heat pump to make this one step 5 compliant. So then moving on to the sort of typical single family, or I would say a conventional single family, or starting with conventional design, R22 bat walls, R50 roof, the 1.6 windows, so a slightly higher U value for windows, standard furnace, electric hot water tank, no HRV starting in this one from steps 2 and 3. These examples differ because these are modeled buildings we had already modeled. We didn't want to remodel them and change, because we wanted to show examples that were proven and done. So to go from that to step 4, upgraded the basement insulation a little bit. We had an envelope upgrade only, whereby we increased some insulation, no exterior insulation, but upgraded HRV percentage windows and attic. That achieved step 4. Second one was just adding some exterior insulation, got us there. Third one was just going to triple glazed windows, where a fourth path was just going to a heat pump. So as you can see, compared to the first example, a slightly easier, more options to get to step 4. And then again, step 5, I won't go through all of these. There's a lot of information here, but what I wanted to just highlight is that for this example, to get to step 5, all of our compliance options included a heat pump. So we didn't run any scenarios where we got compliance with envelope upgrades alone, and we went with the heat pump, and increasing heat recovery percentage as well. So moving on to the townhome examples, this was what I call it, the sloped roof townhome, or conventional townhomes. Not a lot of articulation attic spaces for insulation. So starting from, again, similar standard or typical construction, also with furnace, and this one started with cooling. So this is an example that starts with cooling, electrical hot water tanks and HRVs. Step 4, we upgraded mechanical systems and added 2 inch of exterior insulation, or got compliance with a heat pump. Step 5, we added exterior insulation and integrated heat pump, increased efficiencies of the heat pump, or added the high efficient heat pump with domestic hot water, or integrated sort of domestic hot water preheat, and upgraded to triple glazed windows. So you can see a little bit beyond the single family here to achieve step 5 compliance. And then the last example is the sort of contemporary or flat roof townhome. We want to say it with rooftop patios. So again, starting from standard step 2, step 3, 2x4 wall, 2x6 walls, R22.8 built up roof, U value 1.4. This one had a combo boiler, domestic hot water, no cooling, no HRV. So to get to step 4, we added heat recovery and exterior insulation, or went to a heat pump with upgraded triple glazed windows and a slightly increased insulation on the roof. Now, step 5, starting with the path 2 above, so heat pump and upgraded triple glazed windows, we found compliance with also adding exterior insulation and the heat recovery, and HRV heat recovery plus domestic hot water heat recovery. So again, a few more steps to get there on step 5. So that's sort of high level, quick. I know there's a lot of information here. Trying to stay under an hour, but there's lots of info. But just to sort of highlight some of the paths that it takes to meet step 4 and step 5 compliance. There's lots of different options. Like I said in the beginning, it's a non-prescriptive code. And what you need to understand too is a lot of these, when you get into step 4 and step 5, the orientation of your building makes a big difference. Whether the long sides of your building are facing north, south, east, west, huge difference. So it really can't provide a recipe for step code design when you get into step 4 and step 5. It really takes a integrated design process and a lot of thought and analysis early in your design to achieve these targets. But again, still achieve steps 4 and step 5 with conventional designs and conventional products. So that's sort of it for the examples, best practices, lessons learned. Just going to move on to the few extra little topics that I mentioned in the beginning. The first of which is the hot topic, aka overheating or thermal comfort. This is something that is getting a lot of attention in the industry and with government right now, and justified so. So why is it a topic now? Obviously, number one, climate change. The heat dome event in June 2021, the coroner's report indicated I think it was 619 excess deaths over that period. So huge event, very sad, and very important for us to learn from that and take these lessons we've learned from that into moving forward into our designs. Again, why is it topic now? Because not only climate change, but we also have higher internal heat gain. So we have tighter building envelopes with more insulation. That's not to say the air circulation is getting better. The newer buildings with the HRVs and ERVs do a better job at circulating the air. But we have a tighter envelope, more insulation, we have more appliances in our buildings, and we have more people living in our buildings in maybe smaller spaces. So the internal heat gains are greater than they used to be. And, the province of BC has put a lot of research and effort into this. There's lots of research or resources you can look up. There's a document called Be Prepared for Extreme Heat, talks a lot about what you can do both on the individual and government level to prepare for this. And the BC Housing released that extreme heat report. Very important topic. Try not to go into too much here, but I just wanted to mention it because it can't be forgotten when we design our buildings. Yeah, the part 9 of the code, important to note, it does not have a requirement to meet this thermal comfort. Part 3 of the code does, through the Vancouver Energy Modeling Guidelines, which are used to model the buildings. This is where you have to meet, you can't exceed temperature limits by more than 200 hours in your building. So you got to model the building. You have to prove that no unit exceeds that. Note BC Housing reduces that to 20 hours. This table here just shows the actual temperature limits. So not something that's currently baked into the Part 9 code like it is in Part 3, but something that should definitely be considered. What are people doing? We are adopting high temperature limits, so the code will be introducing these high temperature design limits into the code. I believe this limit's going to apply to one room within a building only for now. So when you're building a single family or a townhome, that may mean one room, one bedroom, living room, whatever it is, may need to meet these high temperature limits, i.e. active cooling. Part 3 buildings, that may mean just one amenity room or one sort of room of cool refuge. Refuge may need to be provided so that occupants in an apartment building can cool down in these cooled rooms. Again, won't go into too much detail here, but just want to mention that some people are including cooling ready designs, provisions for occupants to install heat pumps in the future, or even simple as putting provisions for people to connect portable AC units, recognizing people are going to buy portable AC units to deal with overheating, and providing provisions so that these can be connected through the wall and not having to use a window or a door to exhaust those. And so again, lessons from Part 3, where we are mandated to address this. Obviously, exterior shading elements are the most effective. Exterior blinds, passive, other than active cooling, passive elements include exterior shades, blinds, passive cooling strategies in your buildings, or operable area of windows and doors, low solar heat gain glass. If you do end up having exterior insulation on your building, consider where you place your window in the rough opening can improve shading on your glass. And yeah, obviously just want to reiterate that there's simple solutions to address overheating, such as exterior blinds or shutters and overhangs on buildings. So these are, of course, solutions that have been around for a long time and are relatively simple to employ to address overheating. And then lastly, or almost lastly, again, just a quick mention of rebates. Ajean's presentation there had a good slide on townships resources. There's most importantly, betterhomesbc.ca is an excellent website, can help you navigate all the rebates that are likely available to your development. So thankfully, there's some relief in with rebates through Fortis and BC Hydro. Township of Langley has, I believe, some incentive when you go to step 5. And so important to just check that website out and make sure you utilize all the rebates that are available to you when you're building step 4 and step 5. I think a note here that maybe some rebate programs do run out of money. So I think the BC Hydro one is subscribed for 2023, but keep that in mind when you're researching your rebates. And lastly, just reiterate the importance of integrated design. So engaging consultants early, choosing the appropriate consultant, starting with the right design, and doing this integrated design process can help you improve your application at BP, and maybe avoid any rejections or delays in your BP application. And just to state that you can still achieve step 4, step 5 with sort of quote traditional designs. We can do it with what we're building now, just with a better IDP process and some more thought in the design and planning of our projects. So thank you Township. Thanks everyone for listening to me, and I think I'll pass it back over to Kevin or Jean and to wrap it up.
Thanks a lot, Pat. That was great. We learned a lot today, and I think that stimulated quite a bit of dialogue and questions in the chat. So we do have a bit of time. So if we can put you and Jessica on the spot to answer some questions. And by the way, folks, thank you so much for your questions, and keep them coming in. If we don't get to all of them now during the actual workshop, we will get to them later, and we do have a follow-up, and we do answer all questions and have them in a document later. So don't be discouraged. I do see it's at least 1 or 2 folks with a hand up, and I'm presuming that's because they want to ask a question live. So we'll start with Baldwin Hum. I believe you are live now, Baldwin, so go ahead and ask your question.
Okay, great, thanks. Just looking at the upcoming requirements for increased installation in the exterior walls, I'm wondering if the township is working, or the building department rather, is working with planning to sort of deal with the setback issues that this might raise, given that thicker walls would either mean smaller interiors or sort of closer, more intrusions towards the property lines. Thanks.
Okay, thanks for your question, Baldwin. So I think if you're referring to insulation values prescriptively, and chime in if you're asking for a different question, but if you're speaking about prescriptive values or prescriptive requirements for insulation values, the township is not adopting the prescriptive part of the new code. So it's still performance-based. So the applicant still has options on how they meet their TEDI values.
Right. I'm just thinking about some of the situations that we've seen in other municipalities where there are these requirements for increased insulation for whatever reason, and you're on a smaller site, for example, where the existing setback requirements become somewhat onerous for the builders, for the homeowners, because you have your whatever distance from the property line, and you are now required to either to provide more insulation. And this partially is, I think, a lack of coordination between zoning or between planning and building, as it seems like there's a lot of back and forth that should be happening that isn't happening. I wonder if the township is dealing with this at all proactively before this really starts to take effect.
Thanks for your comments, Baldwin. So currently there are no provisions that intersect with the notes that you're making. However, your comments are noted. Okay, our second question is from J+S Architect. I think your mic is on. Is that right?
You can unmute yourself. Okay.
J+S, are you able to hear us? Or Jean, maybe you could just send him a note and we'll move on to some of the questions in the chat. Okay. So Jessica, thanks so much for answering a lot of the questions live as they've been asking them there. I think there's quite a bit here in the chat. I'll just see some of them that hadn't got an answer, and I'm pretty sure we won't get to all of them today, folks, but you will get a response in an upcoming document. Where do we go here? So I saw an interesting question. It's not right in front of me, but it did stick out. It noted the question was for folks who are installing high CFM kitchen hoods, I guess for a kind of a large operation there in their kitchen. How does that reconcile with very high air tightness targets, or otherwise, how do you get flow through the hood?
Sorry, Jess, do you think you can answer that one from a Hot 2000 perspective?
Talking about makeup air for a kitchen fan. Most Part 9 buildings don't have makeup air designed for fans like that, so it just puts the building under negative pressure until it equalizes again, which can be an issue with like combustion appliances. So your energy advisor can do a depressurization, an exhaust depressurization test that just gives a warning to look out for combustion gases in situations like that. It's just when you turn on all the fans in your house and they don't have makeup air for them, it will depressurize the house to a certain degree.
Okay. The other question, maybe they're asking is, are you penalized for using a high CFM kitchen exhaust hood in Hot 2000?
The flow rate for the exhaust fan is typically a set flow rate from EnerGuide.
Regardless of what product is installed in the end? Yeah, okay.
I
think that's your answer.
Thanks, Jessica. Okay, another question following that, and this was around, Pat, your discussion around HRVs and ERVs and the kind of the general difference here. So this person asks, ERV for humidity control on flooring, or I'm assuming would an ERV solve humidity issues for flooring?
For flooring, sorry, is that what you said?
Yes.
Yeah, again, like I said, really need to take into account the humidity design when choosing HRV, ERV. If your flooring doesn't like humidity and it really needs a dry conditions, HRV may be better. If too dry is bad for your flooring, then maybe ERV is better. But not just flooring, but also occupant load and type of space or usage in the space. Like, for example, if you, maybe not a Part 9 project, but in Part 3, if you have a very high humid expected environment, choosing an HRV versus an ERV is an important decision.
We don't have the slides up, but this was when, Pat, you were showing some of the models you were discussing. Constantine asks, what did you add for underslab insulation in these models? I'm not sure exactly which building he was referring to, but If you could speak to maybe at least the Part 9 ones, that would be great.
Oh, yeah, I didn't have the slab installation on the slides, but Jess did the models. So do you remember, Jess, what slab installation we had on these?
They were varied. Typically it's R15 or R20 continuous, depending on how hard it was to meet step 3.
Yeah, I think we started R15 for most developments and we go up to 20, but it's important to note that it's the full heated space. So when you get into higher steps in the step code, you need to have the installation fully under the heated space slab on grade rather than just around the perimeter. That's one of the main differences coming from the old code to the new step code.
Yeah, we usually do model continuous insulation under the slab.
Thank you. This question was answered, but I do want to just highlight this live in the workshop here because I think it's just important to highlight. Andrew asked how you reconcile PTAC exhaust ports with airtightness requirements. It's a big hole to put through the envelope, and that's right. And Jessica gave a very a really good answer, and I just want to highlight this for the group. And she notes that is definitely something that needs to be looked at when designing the mechanical systems. PTAC penetrations can be difficult to seal properly and can have a negative impact on air tightness. The design team should look at this type of detailing early on when looking at the air tightness requirements and mechanical equipment selected. Just to highlight, there are certainly more and more reasons to practice IDP and get the conversations started early in design. Okay. I'll just Kevin Lanehorse asked, when is Township of Langley going to step code 4 on Part 3 buildings? We do not have immediate plans to go to step 4 for Part 3 buildings. Okay, there's quite a bit, maybe more here going. I'll select one just right in front of me here. This question for Jessica or Pat: would an HRV solve the problem? Oh, okay. Well, so this is back to the question about the hood fan. Would an HRV solve the problem with depressurization from just depressurization from the hood fans?
An HRV is balanced ventilation, so it brings in your code required ventilation and then it exhausts the same amount. So it's a balanced system. It doesn't really increase the amount of ventilation when you're turning on a kitchen hood fan or something like that.
Thanks, Jessica. And I think this will be the last question we answer. We take before we close. So this Nelson Wall asks or notes, BCBC requires active makeup air with a solid fuel appliance and solid fuel appliance in some circumstances. How would you reconcile this? TECA checklist shows when this requirement is necessary. How would the CEA take this into account?
So solid fuel as in like a wood burning furnace or something?
Yeah. Like Nelson, if you're listening to that, you can put your hand up and maybe clarify for us.
I think someone just commented, yeah, wood stove or a fireplace.
Okay, there is actually Nelson. He did put his hand up. Nelson, can you speak?
Yeah, you can unmute now.
I am not particularly sure how that would be dealt with. I haven't modeled a solid burning wood fuel fire or a furnace or anything like that. They're not very common in this area. So I'd have to look into it if I were to be modeling that.
Okay, so maybe
we're still getting them is what's happening. And this is something that we're trying to reconcile with the people in the field because they never actually specify that it's not going to be a sealed unit until we get out on site.
I have done one fireplace and it was a wood burning fireplace, and the building did not have makeup air. It was just a single family house, but it didn't have makeup air just for that fireplace. And the fireplace had a built-in damper to close for the air tightness test. So that was how we did that one.
So I would assume then that if active makeup air was required, as somebody noted, because it's a mechanical component, it could be sealed at the time of the air test because it wouldn't necessarily be engaged at all times. It's only when the excessive CFM from the hood fan creates that negative pressure that it would be active.
I think if you're getting into active makeup air, it's something that we would have to, like as an energy modeler, discuss with your mechanical designers. Because we wouldn't really design systems like that. We would just look at them and figure out how to model them as accurately as we can.
Yeah, these are single family dwellings, so there really isn't a mechanical designer.
Yeah.
Tin
Yeah,
basher that's out there doing the work.
Yeah, I think to answer one of your questions would be, you likely would be on side by tape sealing that solid burning fuel appliance up for the test, for the air tightness test.
I wouldn't think you'd be able to seal the wood burning appliance because it's not a required mechanical component other than the actual makeup air fan that would be the required mechanical component.
Yeah, but again, non-Energuide. Yeah, if you're Energuide, you can't seal anything. You got to run the test at sort of operating conditions.
Right.
So that would be a very difficult thing to pass the test under Energuide.
Yeah, thank you.
Get a lot of leakage. Yeah.
Thanks for the question, and thanks, Pat and Jessica, for your answers. It looks like we're at the end of our day here, so I'd like to wrap things up. And folks, I think there's probably at least another handful of questions in there. We will address them in a follow-up document. So I just want to highlight, well, thanks again for everybody for attending. I think this is probably by far one of the largest or the largest event we've had in terms of participation. So thanks so much. Just a few closing items before you leave. As noted, we have our Step 5 on-site workshops. You are the first to hear about it. You have first access to register. Jean's going to put the link in the chat there. Again, as noted, if you're a larger company, please try not to send your whole team. Send a rep. And make sure that when you are registering that you do belong to one of the target audiences, because our registration is very limited. If you're a building official, you'll get a separate type of access through your association directly to you. Also, please participate in our survey to help us process new materials and the BCBC to provide a report back to you to help you make more informed choices. Again, the survey link will be in the chat. That survey is open only for a short amount of time, and we do need your help. So please spend the time to fill out the survey. We really appreciate you attending today. Look out for a follow-up, and we will answer your questions in a follow-up document. And again, thanks to Pat and Jessica from AquaCoast for delivering a really awesome presentation. We had lots of dialogue in the chat, so we could tell that you were engaged and you got something from it. And thanks again. Everybody, have a good rest of your day.
Thanks, everyone.
Thank you. Thanks for the opportunity.